Hello ladies and gentlemen, my name is Jaleel Simon and I will be presenting my topic on the standardization of a method for the identification and classification of microplastics via oyster tissue in Caroni swamp, Trinidad. So without further ado, let's get right in. Plastics are everywhere in the world. An article from Hannah Ritchie and Max Rosa stated that as recent as 2015, 381 million tons of plastic are produced yearly. For context, that is roughly equivalent to the mass of 2/3 of the world's population. Microplastics are defined as plastic particles which are less than 5 mm in diameter. The Environmental Protection Agency has suggested that microplastics may have arisen from the disintegration of larger pieces as they weather from the effects of ultraviolet rays, wind, and wave action. Microplastics are present in a variety of products, from cosmetics to synthetic clothing to plastic bags and bottles. How do they enter the waters of the world? Kara Rogers suggested that many of these products readily enter the environment through a result of poor waste management. Are they bad for humans? Well, Sarah Gibbons thinks it may be possible that humans may be consuming anywhere from 39,000 to 52,000 microplastic particles a year. Why oysters? Well, microplastics cannot be digested by oysters. Since oysters are ever present in waterways, it makes it an essential organism to look at for testing microplastics. Oysters and mussels are bivalves. Bivalves belong to the class Bivalvia, which are characterized by a shell that is divided from front to back into left and right valves. Oysters and the rest of bivalves are abundant globally. They occur in all depths, in or upon virtually all substrates. In shallow seas, they are often dominant on rocky and sandy coasts and are also important in offshore sediments. Oysters are very easy to catch. In our case, as they were on the roots of mangroves, we simply just had to break one root and peel off the oysters from it and place into a bucket. Oysters are bioindicators. That is, they are species that are used in the biomonitoring of the environment. In order to evaluate how contamination exists spatially, sessile species are the best. Since oysters can be easily tested, we will test 3 digestion methods, which we'll talk about later, against these oysters. So my objectives are to conduct 3 methods of digestion, which are the peroxide digestion, nitric acid digestion, and enzymic digestion to the oyster tissues, and to filter and observe these digested tissues under a compound microscope to identify and have a count of the amount of microplastics observed. So the method, we'll start with a brief site description. The Caroni swamp is connected to the Caroni River, which lies in the northwestern Trinidad. The river rises near Valencia on the southern edge of the northern range uplands and flows roughly west to empty via the saline mangrove channels of the Caroni swamp into the Gulf of Paria between Trinidad and Venezuela, a mile or so south of Port of Spain. The Caroni swamp is the second largest mangrove wetland in Trinidad and Tobago and is protected under the Ramsar Convention as a wetland of international importance. Now on to the method. There are 3 proposed methods to find the most viable one. The first method is peroxide digestion. In this, 50 grams of oyster tissue was shucked and placed into a 250 ml beaker. This was done 3 times to obtain 3 samples of 50 grams each. The sample was placed onto a heating plate and heated to 50 degrees. These first 3 steps of the procedure will be replicated for all other digestion steps. Hydrogen peroxide was added at 35% strength. Around roughly 30 ml of hydrogen peroxide was added to the oyster sample while stirring. The sample was left at 50 degrees for 5 hours. The sample was then removed from the heating plate and using the vacuum pump setup, the sample was filtered from a beaker through a 5 mm sieve onto a 0.7 mm filter paper. The filter paper will be transferred to a petri dish where it can be observed through the means of a compound microscope. For nitric acid digestion, after repeating the first 3 steps from the peroxide digestion method, prepare the nitric acid at 69% strength and add 20 ml to the sample. After adding the sample, the next steps are the same as the hydrogen peroxide digestion. For digestion with enzymes, steps 1 to 3 should have been repeated from the hydrogen peroxide digestion. Then, add the protease at 2 ml per 35 grams of tissue to the sample. Add lipase at 1 ml per 35 grams. Add tween at 100 microliters per 35 grams, which is roughly 1 to 2 drops. Add tris buffer until the pH of the mixture reaches 8.2. Leave the mixture at 50 degrees for 24 hours after. Then we will be repeating the same steps from the digestion of the hydrogen peroxide after removing the sample from the heating plate. Now results. So, tables such as the one on the screen would have been made for each replicate to show how much tissue each sample had in it. It was already done for the peroxide digestion. After adding peroxide and heating for 24 hours, the samples will have looked like the picture shown. The peroxide at this stage is digesting organic materials in the tissue. Some sludge remains due to the nature of some of the contents in the tissue. Once filtering was complete and it was time to observe under the compound microscope, we would be looking at each entity on filter paper and looking at their colors and trying to figure out their type. So, the 7 most popular types of microplastics for the purpose of this experiment are polyethylene terephthalate, which are used in soft drink bottles mostly, high density polyethylene used in grocery bags, the very popular polyvinyl chloride or PVC as we all know, used as piping for houses, low density polyethylene, which are used in squeezable bottles, polypropylene, which are used in car parts, polystyrene, which are used in food containers, and lastly polycarbonate, used to make greenhouses. Now what should have happened? Well, due to unforeseen circumstances, we couldn't finish testing. So upon the completion of testing, I could have shown you how certain samples would have looked during each phase. Theoretically, having done an experiment prior when assisting a fellow student, we know that the nitric acid would have looked similar to the hydrogen peroxide digestion. We also know from helping another student that the color change observed from the tests with enzymes would have had a brownish color. Tables and graphs would have been used to compare each digestion method with each other, most notably looking at their sizes, colors, possibly type, and how much was observed. The method blank would have also been used to show any levels of contamination due to exposure from likely sources such as air, the lab coats, or anything else. The method blank's level of contamination for each method could show either which method accounts for the least amount of contamination, as well as tell us a rough idea of how many or what type occurs on the filter paper as a result of contamination. So, studies from around the world. Firstly, we will look at China, who investigated microplastic pollution in the mussels from 22 sites along 12,400 miles of coastlines of China in 2015. They found the number of total microplastics varied from 0.9 to 4.6 items per gram and from 1.5 to 7.6 items per individual. They noticed the abundance of microplastics was 3.3 items per gram in mussels from the areas which were intensive human activities, significantly higher than the 1.6 items per gram with less human activities. The most common microplastics were fibers, followed by fragments. The proportion of microplastics less than 250 micrometers in size ranged from 17 to 79% of the total microplastics. Diatom was distinguished from microplastics in mussels for the first time using scanning electron microscope. Their results suggested that the number of microplastics kept within a relatively narrow range in mussels and were closely related to the contamination of the environment. They proposed that mussels could be used as a potential bioindicator of microplastic pollution of the coastal environment. China's research looked at the microplastic content in each individual mussel, which was interesting. Next, Brazil. The mussel perna was used as a bioindicator to investigate presence of microplastic pollution in the Santos estuary, the most urbanized area of the coast of São Paulo state in Brazil. A simple assessment showed that 75% of all sampled mussels had ingested microplastics, an issue of human and environmental concern. All sampling points had contaminated mussels, and this contamination had no clear pattern of distribution along the estuary. This was the first time the microplastic bioavailability was assessed in the nature for the southern hemisphere. This is an important issue that should be better assessed due to an increase in seafood consumption and culture in Brazil and worldwide. Now lastly, I want to look at the importance of this research as well as any recommendations. Microplastics have the potential to be extremely hazardous to human health. Studies from China show the amount of microplastics taken up by these organisms are alarming, considering their potential sizes and amount of them. Gathering more info can be crucial. The study in Brazil talked about the importance of assessing this issue due to an increase in seafood consumption and culture in Brazil and worldwide. I think once brought into the limelight, it can help to further minimize plastic use as well. The method can be more efficient when identified. Methods other than observing through microscopes, where more advanced technologies can be used to identify plastics filtered. The best method selected can go through further analysis to standardize and identify microplastics using oysters as an indicator species along the way. I thank you for listening to my presentation. Good day.